Hello, my name is Rob Reynolds. Welcome to Mat-073. We're going to look at section 1.4 today, which deals with inequalities. And an inequality is similar to an equation, but we're going to be dealing with less than or greater than or not equal to. So that's what an inequality is. We're going to learn about interval notation and then how to solve some word problems with inequalities. So again, examples of inequalities are anything that says the function is not necessarily equal. It could be greater than or less than. Now it could be equal to it. Here it says c is equal to 7, but it's also including any values that are less than 7. And remember, not equals is also a great inequality. So we're going to be looking at solution sets for some solutions again of inequality, just like we did for equations. So the first example of an inequality is to determine whether 5 is a solution or not. So we're just going to do some direct substitution here. 3 times the 5 plus the 2 and see if that's greater than 7. So is 15 plus 2 greater than 7? You bet. 17 is always greater than 7. So I would say, yep, that's a true statement. And good. So therefore 5 is a solution. And next we're going to learn how to graph inequalities. I'm going to look at all the values of x that are less than 2. So I have to include this point. This is less than 2. This is less than 2. This is less than 2. In fact, this point is less than 2. This point is less than 2. Everything right up next to 2 is going to be less than 2. But instead of using an open dot and a closed dot, by this level of mathematics, we're going to start using, instead of open dots and closed dots, we're going to use parentheses. So I would use everything up to, but not including 2, and then shade everything to the left. So it's kind of like, well, I'm not including the point that's exactly on it, and that's why it's kind of bending a little bit. So this is called inequality notation. So this is set builder notation. So you can say all the values of x that are less than 2. But instead of doing an open dot, let's get used to the parentheses. For those that are just less than, the next example we might look at less than or equal to. So let's start using parentheses and brackets for those things. So again, if it's just a between statement, I want all the values of x that are between. This is the 3L rule. Put the lower number on the left and use less than signs. Put the lower number on the left and use less than signs. And in fact, you can remember that this is less than because I can write less than for all of these things. So put the lower number on the left and use less than signs. And you can remember that that is less than because that looks like the less than sign. So that's how to write a between statement. We put the lower number on the left and use less than signs. But remember, I'm not including those values, so instead of doing open dots, we're going to use parentheses. If I want to include and put closed dots there, then instead of a closed dot, we're going to use a bracket. Sometimes you have a parentheses on one side. You cannot include A, but you can include B, and vice versa. You can include A, but you can't include B. If it goes to infinity, that's fine. Just put an arrow at the end, but here you cannot include. You cannot include. By the way, you can never include infinity. So every time you see an infinity symbol, it will always be a parentheses because you can't ever reach infinity. So here I want to write this in interval notation. So they're giving this to me. I'll read this x such that all the values of x are between 3 and 8. So to write this as an interval notation, I'll say I want all the values between 3 and 8, and I can't include 3 and I can't include 8. So this kind of looks like a point, like I'm going to plot an x and a y value, but it's not an x and a y. It's called interval notation. The interval that I want here is all the values that I can start with 4. So notice I can include the value of 4, where before you could not include the 3. But I want to go to infinity all the way to the right. Remember, you could never include infinity. So I would choose a bracket on the 4 and go to infinity. Next, we're going to look at how to solve inequalities. Remember, you can add or subtract to any inequality. So if x is being increased by 6, I'll decrease it by 6. Nothing happens to that inequality sign when you subtract. Later on, we're going to look at if you divide by a negative, then you flip the inequality sign. But if you just divide, you keep it the same. But it's only that negative, which we'll explore in just a moment. So next, we're going to graph this. So this is kind of a two-part. It says first solve it, then, that's part one, then we'll graph it. So I think we've solved it. Graphing it, we're going to put a parentheses and go greater than all the values that get greater than -4. So again, solving it, x is greater than -4. Graphing it, don't include the -4, and greater is to the right. So to solve inequalities, it's the same rules for solving equations. And if you watched my earlier video, the first step we want to do is to simplify, which again means to combine or distribute. I should probably distribute and then combine. Step 2 is get all the variables on the same side. So the hint was get rid of the smaller variable. So the smaller variable here is 3x. So to get rid of the 3x, we're going to subtract that off from both sides, giving me just x minus 1 is less than or equal to -4. The third step is to add or subtract, and then the last step is to multiply or divide. So finishing this up, I'll add 1 to both sides. Remember, nothing happens when you subtract or add. It's only when you multiply by a negative or divide by a negative do I flip the inequality sign. So I'm going to keep this less than all the way through. -3, this time it's equal to it, so I'm going to put a bracket on -3, and I want all the values that go to the left. So that means if you were to check a -5 and put a -5 in here, you should get a true statement. -6 will make this true. In fact, all those values to the left of in fact, -3 should make it true as well, because you can include the -3. So the solution set is x such that x is less than or equal to -3, or you could have written the solution set as -infinity all the way up to and including 3. So this is inequality notation, and then this is interval notation. Next, we're going to look at how to solve inequalities using multiplication and division. To solve this part A, we're just going to divide by 7. Nothing happens to the inequality sign when you divide by 7. But this one, and then you could graph this. This one is a little bit different because if you divide by a negative, you're going to flip the inequality sign. So it was a less, it goes to greater, and 20 divided by -4 is -5. Explore what's happening here. If we agree that 4 is less than 5, if I also agree that I can multiply both sides by -1, because I can do whatever I want to an equation or an inequality as long as I do both sides. Notice I get -4 on this side, -5 on this side, and then if I talk about which one's lower, which one's further to the left, -5 is further to the left of -4. So notice that my inequality sign needs to flip because -4 is greater than -5. So again, there's the if you multiply both sides by a negative or if you divide, and that's certainly what we did here. We divided by a negative. So keep in mind, we need to flip from less to greater every time you multiply by a negative or divide by a negative. And I think we've got those graphs. So there's part A, and here was the correct answer for part B. Notice they flipped this inequality sign from less to greater. All right, our next example, we're looking at variables on different sides. So we've got to get rid of the smaller. So I've got a 3x and an x, and I'm going to get rid of this x term by subtracting that off from both sides, giving me 2x minus 3. Nothing happens in the inequality when you subtract. It's only when you multiply and divide through by a negative. I'll add 3 next for a total of 10. And be careful, you don't flip the inequality sign when you divide. You have to divide through by a negative in order to flip the inequality sign. So for this problem, I cannot include the 5, but I want all the values that get greater than 5. I'm almost off my graph here. The graph would look like this. The solution set would say I cannot include the 5, but I want to go to infinity, and I can never include infinity. So that's interval notation. Here's set builder notation, x such that x is greater than or equal to 5. I personally like interval notation a little bit better. This problem is a little bit harder because remember, step number 1 was to simplify, which means I need to distribute and combine like terms. So the first thing is I'm going to distribute this for a 5x minus 15. I'll distribute the 4. Combining some like terms, 5x take away 7x, signs are different, subtract, keep the sign of the larger. And negative 12 plus 9 is negative 3. Again, signs are different. Subtract, keep the sign of the larger. Step number 2 was to get all the variables on the same side, and the hint is get rid of the smaller. So which is smaller, negative 2x or 4x? Negative 2x is further to the left, so I'll add 2x to both sides. (4x) and 2x is 6x. The next step is to add or subtract, and then I'll multiply or divide. So I can see this x term is being decreased by 3. So increasing it by 3, signs are different, subtract, keep the sign of the larger. And my last step is to divide through by 6. Remember, you do not flip the inequality sign if you divide. It's only if you divide through by a negative. So this is interesting because the inequality sign's on the, or the x, the variable's on the wrong side. So notice I'm going to take this answer, which is the correct answer, but I would much prefer you to write x is less than or equal to negative 2. See how this arrow is pointing to the x? I still point the arrow to the x. I'm just flipping the x on the opposite side so that when I go to graph this, I can see I want all the values of x that are less than. A lot of times students think, well, this arrow is pointing that direction, so I'm going to put my arrow that direction. And that's true only if x is on the left. So I'm going to put a bracket on this negative 2 and say I want all the values that are to the left of negative 2. Again, interval notation would be I can include all the values from negative infinity, everything over here, all the way up into, because remember, I'm going to write this from left to right. You can never include infinity. And then I'm going to decide, well, since I have a equal sign here, I'm going to put a bracket, interval notation. This looks like the answer to the previous problem, which we'd already done, so I don't have the answer for the author's answer for that last problem at work, but I think that's probably correct. Careful, you need to know a couple terms. At least means it could be equal to it. If you see someone in the street and you say they're at least 16 years old, they could be 16, but they could be anything greater than 16. If someone's at the mall and you say, oh, that little girl is at most 3 years old, they could be equal to 3, but that means less than. Cannot exceed is less than. Must exceed is greater than, but not equal to it, just greater than. Between, we talked about that. Put the lower number on the left and use less than sign. That's that 3L rule. More than, it could be equal to. No, excuse me, no more than. More than would be, it cannot be equal to, but no more than. 560 is no more than 560, so that's why it's equal. And then no less than is also have an equal sign to it. So translating at least and at most is usually the difficult part. So we'll focus in on those. Here comes an example. Save a Lot offers 2 different checking account plans, a plan A and a plan B. So let's explore plan A and plan B. For plan A, we've got 25 cents per check. So I'll say 0.25 for every check that you write. And plan B costs $3 per month. So no matter what, even if they don't write any checks, it's going to be $3. But it's significantly less. It's only 0.05 for every check that they write. So it says, for what numbers of checks per month will the plan A, so I want plan A to be less than plan B. And plan A is my 0.25x, and I want that to be less than 0.05x plus 3. So I'm going to try to solve this. Again, getting all the variables on the same side, I'm going to get rid of the smaller variable, which is the 0.05. So I'll subtract that off from both sides, and I'll get 0.20x is equal to 3, and my last step is to divide by 0.20. Let's see, this is an inequality sign, so this is less than here. And when I divide by 0.20, nothing happens to the inequality sign, so it just stays less than, and I believe 3 divided by 0.20 is 15. So what does that 15 mean? Again, for story problems, you need to go back and figure out the units and try to answer the actual questions. So the author here said, oh, well, let's just guess 20 and see what happens, which sometimes is a good method. But I would like for you to have a stated solution, and they asked which plan is better. And writing less than 15 checks per month will make plan A better. So that's how to interpret it. If you just kind of leave this as x is less than or equal to 15, maybe we're not really answering the question, because it says for what numbers of checks. So it could be, so if you write 15 checks, it's not better. So the answer is less than 15 checks is what's better. I hope you found this video helpful. Email me.